we have the 2016 question on probability that came up. It came up as question 5, and I'm just after drawing in the diagram that they're after giving us in the question. And it says, in an archery competition, the team consisting of John, David and Mike will win first prize if at least 2 of them hit the bullseye with their last arrows. So from past experience, they note the probability that John, David and Mike will hit the bullseye is a fifth, a sixth, and so the probability that John will hit the bullseye is going to be a fifth. The probability that David would hit the bullseye will be a sixth, and the probability that Mike will hit the bullseye is going to be a quarter. So complete the table below to show all the ways in which they could win first prize. So the team will win first prize if at least 2 of them hit the bullseye. So we could have so in this one Mike doesn't hit the bullseye, so maybe the next one David doesn't hit the bullseye, and maybe in the next one John doesn't hit the bullseye, and then maybe in the next one they all hit the bullseye. So in that way they would win again. So, and if we're looking to get so the next question is, hence or otherwise find the probability that they will win the competition. So if we want to get the probability that they will win, we're going to get the probability that they're going to win in way 1, the probability of way 1, and it's going to be or the probability of way 2. So we're going to add the probabilities, or the probability of winning in way 2, or the probability of way 3, or the probability of way 4. So the probability, so we're going to have to get these different probabilities. So in way 1, John hits the bullseye, David hits the bullseye, but Mike doesn't. So the probability that they'll win in way 1 is going to be, probability that John will hit it is 1 over 5. So, and David's going to hit it, so it's going to be and, so we're going to multiply. David's going to be 1 over 6. But then this one, Mike doesn't hit it, so the probability that he hits it is a quarter. So the probability that he doesn't hit is 1 minus a quarter, which is 3 quarters. And the probability that David doesn't hit is 1 minus a sixth, which is 5 sixths. And that John doesn't hit is 1 minus a fifth, which is 4 over 5. So this is doesn't hit. So we're in the first one, Mike doesn't hit, so it's going to be by 3 quarters. And then the probability of way 2. So in way 2, John hits, and the probability that he hits is 1 over 5. And then David doesn't hit, so the probability that he doesn't hit is 5 over 6. And then the probability that Mike hits, which is a quarter, and then that's plus way 3. So in way 3, John doesn't hit, so the probability that he doesn't hit is 4 over 5. And then the probability that David hits is 1 over 6, and that Mike hits is 1 over 4. And then in way 3 they all hit, so it's going to be way 4, sorry, so it's going to be 1 over 5 by 1 over 6 by 1 over 4. So then I'm going to have to tot up all these probabilities together. So it's going to be 1 over 5 by 1 over 6 by 3 over 4, and plus 1 over 5 by 5 over 6 by 1 over 4, and then plus some onto the third one, 4 over 3 by 1 over 6 by 1 over 4, and then I'm on to the next one. So the last one is 1 over 5, so 1 over, so 1, so I'll just put them together, equals, and then plus but then we have the last one, 1 over 5 by 1 over 6 by 1 over 4, and then the total, so the probability, and we add those all together, so we multiply in between our brackets and then add, it's going to be 13 over 120. So that's the probability that they win in way 1, way 2, way 3 or way 4. And then the next part of the question is, so then we have another kind of which is a different, so then we're told that 2 events A and B are represented in the diagram. So I'm just going to draw the diagram here. So we have it A, so the probability, so this is A and this is B, and just this is the diagram that they have here. And they're after saying that the probability of A intersection B is 0.1. The probability of B, so the probability of B and this dash here is B less A. So B on its own, B without A. And then similarly it says the probability of A without B is X. Write the probability of A. So we want to get the probability of A in terms of X, and hence or otherwise find the value for X for which the events are independent. So the probability of A altogether is going to be the probability of X plus the probability of 0.1. So the probability of A is equal to the probability, so it's going to be just X plus 0.1. And then independent events, if events are independent, the probability of A multiplied by the probability of B, so this is the definition of independent events. Independent events, the probability of A multiplied by the probability of B equals the probability of A intersection B. So they're saying that write PA in terms of X. So we've wrote probability of A in terms of X, and hence or otherwise find the value of X for which A and B are independent. So the probability of A by the probability of B is going to be the probability of the intersection. And we see in our diagram that the intersection is 0.1, so we can fill that in. And then the probability of A is going to be X plus 0.1. X plus 0.1, and the probability of B is going to be 0.1 plus 0.3, so it's going to be 0.4. So now we just kind of have to fix that out. So it's going to be X by 0.4, so 0.4x, and then we're going to have 0.1 by 0.4, so that's going to be 0.4x plus 0.04, and that's equal to 0.1. So I'm going to put x's on one side, I'm going to move my 0.04 to the other side, so 0.1 takes 0.04, and that gives me an answer of 0.4x is equal to 0.06. And now I'm going to divide both sides by 0.4, so 0.6 divided by 0.4, and I get an answer of 3/20, or it's 0.15. And I think that's the last part of that question, and yeah, that is our question. Thank you.